So, what if I told you that the frustration you feel waiting in a line is actually governed by the very same math that decides whether a species lives or dies? It sounds kind of crazy, right? But it's absolutely true, and we're about to see exactly how. You know that feeling. You're stuck in a queue, just staring at the back of someone's head, and you start to wonder, will this thing ever end? It feels like a total test of your patience. But the answer has nothing to do with psychology. It's all about math. So, to figure this out, mathematicians have a concept called a busy period. Just think of it like this. It's one wave of customers. It starts the second the first person walks up to an empty counter, and it only ends when that last person from that wave is gone and the server is all alone again. And that brings us to the big question, right? Is that busy period always guaranteed to end? Or could it, in theory, just go on forever? Well, the answer all comes down to one single, surprisingly simple idea. And that one powerful factor, the one that decides the fate of the entire line, is what we call traffic intensity. So this is represented by the Greek letter rho, and you can basically think of it as a tug of war. On one side, you've got the arrival rate, that's how fast people are getting in line, and on the other, you've got the service rate, how fast the server is getting them out. And this one number, it's crucial for everything from designing call centers to managing internet traffic. And here it is, the critical tipping point. If people are arriving at the same speed or slower than they're being served, we call that slow traffic, then the line is absolutely guaranteed to end. But the moment people start showing up faster than they can be served, heavy traffic, the whole system gets unstable. The queue might just grow forever. Okay, now this is where it gets really mind-bending, because this exact same mathematical rule doesn't just work for lines at the store. It also works for family lines. It turns out that the models that mathematicians use to describe the length of a queue are, well, they're identical to the ones they use to describe the size of a population. A line of people is, mathematically speaking, a family tree. And the translation is perfect. It's one-to-one. That first person in line, that's the first ancestor. Every new customer who arrives, that's an offspring being born. And the end of that busy period, when the server is finally alone again, that is the mathematical equivalent of the family line going extinct, which means the chance of the line ending is literally called the extinction probability. And this leads to a pretty stark conclusion, which is summed up perfectly here. These kinds of systems, they rarely just find a nice, stable middle ground. Over the long run, they're really only facing one of two fates. They either die out completely or they explode. And the connections don't even stop there. This same basic idea shows up again in the world of probability and gambling with a concept known as a martingale. Okay, so think of a truly fair game, like flipping a perfectly balanced coin. It doesn't matter if you just got 10 heads in a row, right? The odds on the next flip are still 50-50. The game has no memory, no bias. In mathematics, that kind of perfectly fair game is what we call a martingale. And this classic and super risky gambling strategy is a real-world example. The idea is, if you just keep doubling your bet, one eventual win will cover all your past losses. It's a strategy that's based on the idea of a fair game, even though in the real world, things like casino limits mean it's usually just a fast track to going broke. So we have these three worlds that seem totally separate, right? We've got checkout queues, family trees, and gambling strategies. So what's the one universal idea that ties them all together? It all comes back to that one variable we met at the beginning, rho. Whether that traffic intensity is just a little bit less than 1 or just a little bit more than 1, that's the whole ballgame. The exact same rule that tells you a line at the bank will end also tells you if a species is going to survive. But here is the last and maybe most fascinating twist. Even in one of those unstable, heavy traffic systems, it's not actually doomed to explode. Pure random chance can still save the day. A lucky break where nobody shows up for a few minutes might give the server just enough time to patch up and clear the line. So it's not guaranteed to end, but it's not guaranteed to explode either. And that kind of brings us to this piece of wisdom from the 16th century. For any of these unstable systems that are balanced on a knife's edge, whether that's a gambling strategy or a really busy queue, the odds in the long run are just not in your favor. So that leaves us with one final thought. Now that you know the pattern, where else do you see it? Think about the spread of a viral meme, the fluctuations of the stock market, or even entire ecosystems. All of these systems are constantly teetering on that same mathematical edge between dying out and exploding. And once you learn to spot it, you'll start to see it absolutely everywhere.